So our presentation is about plant-based biofuels and renewable energy sources. So the biofuels that we will cover in these presentations are cyanobacteria-based biofuel, rapeseed-based biodiesel, algal biofuel, sugar-based rocket fuel, and biofuel made from biomass. Algal biofuel. Algal biofuels use algae, particularly marine microalgae, as the source of energy-rich oil. It's used because of its rapid growth and higher oil productivity compared to other crops. Types of fuel that can utilize algae. So biodiesel, renewable diesel, biobutanol, biogasoline, biogas, methanol, ethanol, jet fuel, and algae-based energy harvester. In this presentation, we'll be focusing mainly on biodiesel. Algal biodiesel advantages. You can see a sample of the biodiesel here. A report by the US Department of Energy's Aquatic Species Program found that biodiesel could be the only biofuel that would be possible to produce enough of to replace the current world diesel usage. It would require 57.3 million hectares of landmass, which is the smallest area compared to other biofuels. This is because of algae's unique effectiveness in producing energy-rich oils, with some algae species being able to produce up to 60% of their dry wave in the form of oil. For comparison, soybeans can only produce from 2 to 3% of their wave. They don't have to produce structural compounds such as cellulose for leaves, stems or roots, which allows for faster growth and converting more of their biomass to oil. So the disadvantages of algal biodiesel are that the recent studies indicate that biodiesel made from microalgae produces more carbon emissions than petroleum-based diesel. Another problem is that the manufacturing process of the biodiesel consumes more energy than the final product can produce. This is mainly because of the low efficiency of its manufacturing process. Experts agree that microalgae biofuels cannot outperform conventional diesel without a major breakthrough in the technology. So here you can see a visualization of making algal biodiesel. So first the algae is dried into algae powder, and then using transesterification converted into biodiesel.
Rapeseed is the main source of biojet fuel. It is very popular and is grown in many countries. One variation of rapeseed, called canola, was specifically bred to reduce the acid present in seeds, and thus it is also used for producing cooking oil. Unfortunately, growing this plant in higher quantities can endanger biodiversity and requires an enormous amount of land that could have been used in other ways. However, fuel from rapeseed is much more suitable for colder regions compared to other biofuels, yet it still falls short compared to traditional diesel. One of the main advantages in using rapeseed instead of seaweed or algae is that it produces the least waste, because everything that is not used in production of the fuel can be used as food for livestock, because the waste is rich in proteins. To produce biodiesel, we first need to produce green crude. Most of the ways green crude can be created are found in these two categories, that be mechanical and chemical. Mechanical includes expression, where the substance is pressed the same way as olives are pressed in olive oil production. Certain solvents can also be added to further enhance the efficiency of the process, extracting up to 95% of the oil. This method is fairly cheap, efficient, and the most common. Other method of extraction is called ultrasonic method. It is the fastest and thus the most space efficient method, however it isn't as yield efficient. In this method, ultrasonic waves are used to create bubbles in solvent that force the cell wall to open and release the oil. Green crude can also be produced chemically. This method is probably the cheapest and fastest method. However, it is the most dangerous. All solvents are either flammable or toxic. This method is a bit experimental, however it shows amazing results because it achieved the highest efficiency. Subtle extraction and supercritical fluid extraction are two ways efficiency can be further enhanced. Now, the green crude goes through the process of transesterification, which adds alcohol made from, for example, biomass, and a chemical catalyst that causes the alcohol to react with the oil, creating a mix of biodiesel and glycerol, which is later separated using a centrifuge, purified, and ready to be used.
Sugar-based rocket fuel. It is an easy-to-make, cheap, and non-toxic rocket fuel, mainly used by amateur rocket modelers. Due to its lower efficiency, most advanced rocket modelers prefer using ammonium perchlorate composite propellant or liquid propellants instead. The Sugar's Shot to Space program achieved the highest altitude ever with a rocket powered by a sugar rocket fuel, which is 33 kilometers. It has also been used to power rockets used as crude weapons of war, for example during the attacks on Israel by Hamas in 2000 to 2003. Sugar-based rocket fuel production. The rocket fuel is made from a mixture of sugar and potassium nitrate, KNO3. The optimal ratio of oxidizer, which is potassium nitrate, and fuel, which is sugar, is 65 to 35. Normal sugar made from sugarcane can be used, as it is 99.95% sucrose. The performance of the fuel can be enhanced by using optional additives, such as iron oxide to increase burn rate, or glycerin to make the fuel more pourable. The mixture is then mixed thoroughly and heated until the sugar melts and combines with the KNO3, forming a uniform substance. A safer alternative is to dissolve the ingredients in water, which is then slowly evaporated. The final product is a uniform substance similar to caramel. So here you can see photos from production of the rocket fuel. So here it is before melting, here it is after. So as you can see, it's really similar to caramel. Okay, so this is a video of burning a sample of the rocket fuel. And as you can see, no residue is left, which means the fuel was mixed in the right ratio.
Biofuel can also be created from biomass, which is a mixture of any organic waste. The two primary ways biomass can be transformed into biofuel are chemical, which use high pressure steam to create a carbon monoxide rich gas called synthesis gas, and biological, which uses enzymes, fungi, or bacteria to break down complex molecules to hydrocarbons or alcohols. Synthesis gas has to be later filtered using cyclonic separation to separate char from it. It is then run through a solid catalyst, which breaks down tars and methanol. It is then transformed into various types of biofuel and leftover waste.
Okay, so that's all for our presentation, and thank you for your attention.